Hello everyone, this is Professor Amit Solanki from S&T College of Engineering and Research Center Yeola. Now today we will discuss our next topic of the subject PECD, Power Electronics Control Drives, or we can say that the electrical drives. The topic is that for discussion, closed loop speed control of DC motor below and above base speed. That means in this lecture, we will discuss about the closed loop speed control of DC motor with the point of below and above base speed. This is the main point. Now we can say that the how to control of the speed is the process above and below the base speed. Let us understand the basic approach of closed loop speed control below and above the speed is explained by the drive of block diagram is given below. The drive employs inner current control loop and outer speed loop, right? Such a drive will operate at a constant field current and variable armature voltage below the base speed, and at a constant armature voltage and variable field current above the base speed. Both armature and field are therefore connected from the fully controlled rectifier. Point is to be noted that both armature and field are connected to the fully controlled rectifier. Fully controlled rectifier, that means it can be converted fixed or variable AC, fixed AC to variable DC system. That means it is called the fully controlled rectifier. Since the armature is connected from a fully controlled rectifier, forward braking is not possible. It is to be noted that in case of fully controlled converter or fully controlled thyristor based rectifier, there is forward braking is not possible. The drive will decelerate due to low torque only. The main point is that in that condition, the drive will decelerate due to low torque only. Because of inner current control with current limiter, the acceleration will take place at the maximum permissible current and torque, right? So according to that, we can see in the next slide how it is operated. So first we will take our parameter, that is the operation below base speed. Now we will examine the operation below the base speed. So let us first examine the operation below the base speed. In the field control loop, the back EMF E is compared with the reference voltage E, which is chosen to be between 0.85 to 0.95 of the rated armature voltage. What we say? First, we examine the operation below the base speed. In that loop, the back EMF E is compared with the reference voltage E. So in this figure, you can see here, back EMF E is compared with in that figure, you can see here. Now, the higher value is used for motors with low armature circuit resistance. For speeds below base speed, the field control saturates due to large value of error of EF, and the firing angle of field rectifier, that is alpha F, is maintained at 0. Applying rated voltage to the field, right? So this ensures rated field current for motor operation below base speed, which is denoted by omega mb. When speed difference is increased from omega star m1 to omega star m2, that means omega star m2 is less than omega m1. Due to large speed error, the current limiter saturates and sets the current reference at the maximum permissible value. This is the basic concept of the operation below base speed. So in that below base speed, we can do that as per the description we have given here. Now next most thing is that continue for the operation below base speed. The drive accelerates at the maximum available current and torque. When the speed reaches is close to omega m2 star, the current limiter desaturates and the drive settles at speed omega m2 and at the current which gives motor torque equal to the load torque. Right? If speed reference is reduced back to omega star m1, the current reference is set at 0 and the drive accelerates due to the load torque. When omega m becomes slightly less than omega star m1, the motor current flow again and finally drive settles at the speed of omega m1. And current for which motor torque balances the load torque. Okay. So these are the all about the concept for the operation below base speed. For negative speed error like I star A, it is set at 0 because negative current is of no use. Okay, so this is the operation below base speed. As earlier we have described the operation below base speed according to this diagram. In that, the rectifier we are using the rectifier. This is the control rectifier. AC supply is given, and this is the firing circuit. Okay, so due to that, we can provide the firing angle to the alpha f, that means firing angle. Okay, so this is connected to the armature and field winding. Okay, so in that you can see here, this is the also AC supply is given here. The field is also connected, armature is also connected. There are separately we are using the field control rectifier for their controlling. Now in that we are using the speed controller and current limiter, current controller, firing circuits. That is also the function of firing circuit to control the firing angle. Now this is the totally all about the block diagram of the closed loop speed control scheme for the control below and above base speed. Right? These are the all about the block diagram for the closed loop speed control method for control below and above base speed. Now let us examine or understand the concept for the speed control operation above base speed. Before that, we study the operation below base speed. Now we are see the operation above base speed. So let us now examine the operation above base speed. When close to base speed, the field controller comes out of saturation. Okay. Now if the reference speed is set for speed above base speed, then what will happen? The current reference is set at the maximum permissible value and the firing angle of the armature rectifier is reduced to initially increase voltage VAR, armature voltage. The motor accelerates and EMF increases and E of F, that is the field is decreases, reducing the field current. Therefore, the motor speed continue to increase and field current continue to decrease until the motor speed becomes equal to the reference speed. Since the speed error will now be small, that means armature voltage will return to a value close to original value. So therefore, the speed control of above base speed is obtained by field control with armature voltage maintained near the rated value. The speed control above base speed is obtained by field control with the armature voltage maintained near the rated value. In the field control region, above base speed, the dry responds very slowly due to large value of the field time constant. So these are the all about the concept for the closed speed control scheme for above and below base speed.